Should I start? Okay. So hi, everyone. First of all, this talk, as you can see from the screen, contains some content that might not be nice for everyone. So if you like the code and you don't want it to be mistreated, then just leave now. And, yeah. Because we're talking about zombie code, on better how to survive a zombie code apocalypse in JavaScript. And I want to see that as well. So, first of all, my name is Marco Cedaro. I'm Chad Max almost everywhere online. And I work for Shazam. Do you know Shazam? We work like that all day. And I organize conferences with From the Front, an Italian. Proud of it. And please visit our website, fromthefront.it, and come to the conference. I have a disclaimer to give you before starting. I'm strongly opinionated about stuff. It's a gift and a curse. And if you don't agree with me, never mind. It's just fine. I'm just giving you some ideas I own and I want to share. And there is no thing that is right for everyone. So it's just my opinion about it. Zombies. We all know what zombies are and what they are about. So eating brains, basically. But what is zombie code? So zombie code, in my definition, is not that code. It's code that is not executed. It's code that is online in production. Everyone can see it working, but you don't really want to deal with it. It's code that is called legacy somewhere. Somewhere else is spaghetti code. It's the code that you wrote 6 months ago without tests and anything else, and you don't really want to go through it again. And you know, it's there, it's working, why bother? How can we spot what zombie code is compared to proper coding? Well, it's hard because you know sometimes it doesn't really seem a problem. So what I can tell, again, is that it seems harmless. It seems normal code, but it's not. And at some point, when it gets to be a huge amount of it, will eventually eat your brain. The thing is that it will happen during estimation, during debugging, and during development as well. So it's dumb code that makes you dumb as well. Hopefully, it's not too late for you. The cool thing about zombie code, anyway, is that it smells. Zombie smells worse than anything you can imagine. And so there are a few tips I can give you to recognize it. First of all, the code should be appealing. So if you ever go through your code and see something like this is just one method. There is something wrong with your code. Or, same method again, if you have this amount of ifs in just one method, 14 in one function, really? There is something wrong, and you might want to refactor it. Also, the same method again, this huge amount of comments. Are comments a bad thing? What do you think? Oh, nice. The code should talk to you. That's the thing. So if you ever see code written like that, which I wrote, actually, is my fault, there is something wrong. This is code written for machines, not for people. And, well, this was a game. It was 140 bytes, and was like to write a proper library working in just a tweet. But the original library, so this is a minified version, I minified myself, but the original library was something like that. And if I gave you the time to read through it, you would understand what is happening. While if you look again at this one, I bet it will take, to me, it will take half a day to understand the whole thing deeply. But with this one, with the proper names of the properties and function or whatever else, you can get what happens. So the thing is, don't use the comments to be an excuse to write bad code. Comments are a good thing in a few use cases. For example, to explain unavoidable acts, like you have to deal with something and you want the people that are going to maintain your code to know that they are not supposed to remove that line because something will break. To create automated documentation, or to have reminders in your code to things that should be fixed or should be refactored or whatever. So again, the code should talk to you itself. You don't need comments to explain what's happening. If you do, then there is something wrong. You know you wrote the code. And code should have personal boundaries. What I mean by personal boundaries could be different things. For example, the single responsibility principle is one of them. So your library, your method should do one thing and do it well. So there is this company in Sweden, they produce just axes. And they guarantee them for 20 years. And they do that since 1902. They're kind of focused. And that's a good thing. It's your best tool against zombie code. Then another thing that could be a boundary for your code is the global scope. Don't pollute the global scope. Also, zombies can tell you that the toxic water is a real threat. Polluting the global scope is worse than having zombies itself. And then no coupling. Your code should be decoupled. You don't want baby zombies to walk around, so never couple your zombie code. The point is that over time you will develop a code sense. Uncle Bob says, writing clean code requires the disciplined use of a myriad electrical techniques applied through a painstaking acquired sense of cleanliness. You should get to have this sense of cleanliness and look at your code and say, there's something smelly here. So I can tell you a few things, but you should develop it by yourself. So long methods, we saw that. Deep level of indentation. I don't want to mention cyclomatronic complexity because it's not rocket science, it's JavaScript. But still, if you have your code going deeper, 3 or 4 levels of indentation, then there is something that you could refactor. Anyway, hard to tell what it does. Again, the code should talk to you. Lack of portability. If your code is hardly decouplable and portable to other parts of your application, then there is something wrong. Our code is silent templating. Everyone knows that. Everyone does that? Logic block duplication and callback hell. If you work in Node, you know what I'm talking about. So we kind of have a few hints on how to recognize zombie code, and you might have recognized a few patterns on the code you wrote. I did. And now what? We can spot them. Now it's the time to play cool. And the first thing we should do to play cool is to quarantine our bad code. Most teams are trying to stop further spread only through quarantines. It's a good short-term solution, but it won't prevent long-term population loss. So quarantine is the first step. It's not the only step, but it's something we should try to do in order to block the initial spread. Are you familiar with the concept of the broken window? Anyone? Raise your hands. Okay, cool. So the broken window is a sociological theory that kind of says that if you leave a building with a broken window without fixing it, then the vandalism will spread faster than if you fix it. This was proved by a group of scientists in the US leaving a car in 2 neighbors. One was kind of a poor and not wealthy neighbor. The other one was a fancy one. And in the poor and not fancy, which was vandalism all around, the car was vandalized in the first week. In the other one, in the fancy one, the car was left by itself. No one touched it until one of the scientists went there and broke a window of the car. Suddenly, in the few days after that hacked, the whole car was vandalized. That was because the people around that car felt that no one was caring about the car itself. While in the other neighbor, no one was caring about actually anything there, and so the car was vandalized immediately. And this is a concept that we can bring to our code as well. This is a beautiful article by Jeff Hutwood that claims that don't leave broken windows, bad design, wrong decision, or poor code unrepaired. Fix each one as soon as it's discovered. Programming is insanely detail-oriented, and perhaps this is why. If you are not on top of details, the perception is that things are running out of control. And it's only a matter of time before your project spins out of control. Maybe we should be sweetening the small stuff. That's the core of it. maybe we should be sweeten the small stuff. So, never leave poor decision unfixed. Isolate zombies. What can we do to isolate zombies? Define style guides. It's one of the first and easiest thing to do. So you don't want your code to look something like that, to have random new lines, random underscores instead of camel cases and random spaces. Is that what you want your code to look like? Start linting it. Apply lint to your code to enforce the rule that you decided to introduce, and try to get a way to have your team write the code as one person. It seems kind of control freakish, this thing, but it's not. Actually, it's the opposite. It's on writing the core of our program, which is what we are supposed to do. We're not supposed to care about style. Style should be controlled by machines. Leave it. And then another step we can do to isolate zombies is start testing code. Unit or functional testing? Well, do both. There are a few things why you should do both. First of all, possibly your zombie code is not easily unit testable. And so you may want to cover it with functional tests, because it's way easier to test the whole functional thing, since it's working, actually. This code is not broken. So you may want to do that up front, and maybe start unit testing your new code. How many of you do functional tests, like Selenium or something like that? Okay, a few. Unit testing in JavaScript? Anyone? Okay, cool. A few more. Cool. The funny thing about unit testing and functional testing, if you write them in JavaScript and not directly on Java or Selenium, is that at some point you get to test the same thing. Because unit testing is supposed to test the single atomic unit, maybe a function or something like that, removing all the dependencies around it. The point is that in JavaScript, a lot of times you have dependencies with HTML and CSS. So what happens sometimes, not all the time, but sometimes it happens that you just test what happens when the user interaction occurs, and that is kind of functional test realm. So actually, your code should be portable at some point, and you should be able to move the functional test to unit test somehow. And so yeah, write your code, your test in JavaScript. It's easier. Keep it your language. And it doesn't really matter which tools that you choose. Here I put some stuff that is not even on the same thing. So there are frameworks for BDD, frameworks for TDD. There are runners and whatever else. Build your toolkit and use it. I do use this stuff, but again, build your own. Put them together and figure out what works best for you. And it's not really important which tools you use, as long as they are automatable. So you can have feedback when you commit your stuff or you push your stuff to your repository. And make it part of the process. And by process, I don't mean just technical stuff, again, not just the continuous integration. I mean a process with people, process in the company. So consider your testing during estimation. Do code review with your team. This is fun. And involve people during the whole process. Because you shouldn't fear the living. The people around you is not your enemy. There is a team, probably, you are working with. Who of you is a single freelance not working with a team? Okay, just one. Okay, so the example kind of works. But I believe that you can, so basically you are doing the whole thing by yourself, or something like that. So in a team, there are a few roles that are key to the success of your application. And all of them can be involved in the introduction of this process. So the QA guy is the guy that actually works aside with you, should work aside with you. I mean, he cares about the quality of the product. You care about the quality of the code. This should be the same thing, actually. At some point, the quality of the code will improve the quality of the application itself. So you can get help and help him building the functional suite. And then there is the DevOps, that are the tough guys. It's hard to talk with them, but they're the one that awakened at night if something fails, so be kind with them. And they can help you, and they will help you build in the continuous integration process, because they love to have control. So you're doing this JavaScript stupid toy thing for them, but if you put tests and you show them that you want to gain control, they will be keen to help you and be part of it. And then the key role, again, is the product owner, is the less interested in the code itself. The point is that with a person like having that role, you should bring numbers and not theories. So measure your time, measure your code. And yeah, at the beginning, testing stuff will raise a little bit the time it'll take to you to write code. But at some point, making changes to the code that is tested is like, an immediate thing. Because you have test coverage, you won't be scared of breaking anything. So the product owner can help you a lot staying focused. I mean, when you go through the path of refactoring stuff, you could get to a point in which you just refactor stuff for the sake of it. And this is a bad, bad thing. The focus is still the functionality and pushing out stuff. It's not the code quality itself. Then there are other people in the team. There are juniors, external lobbyists. So the juniors are fairly important for the company. They are the future of your company. Pair with them, code review your code and their code. Involve them during the definition of the process. They are very important to keep things simple. And again, not going to the path of refactoring for the sake of it, introducing complexity for the sake of it. And then external lobbyists, they slow you down. Your brain will be hidden. Redirect them to the product owner. The product owner is the one that should deal with everyone that comes to your chair and asks for a favor. So if someone comes to you, let's do this, please, legal stuff is important. No. That's the product owner, deal with that. That's kind of a way to isolate yourself and your work and your code, but at some point you should get to kill them all. Keep calm and kill zombies. Nothing is impossible to kill. But a goal without a plan is just a wish, so you should design for your goal. Without requirements of design, programming is the art of adding bugs to an empty file. Please, on a pause for this guy. This is amazing. Design for your goal. Think about design, patterns, and whatever it takes to write better code. I'll leave you a few tips. For example, modular architecture. Anyone is familiar with this slide? Have you seen it before? So this is Nicholas Zaka's scalable JavaScript application architecture. It's a different shift from the standard MVC stuff that we see around these days. Basically, the concept of it is that there are modules that contains the business logic, and they're sandboxed, and then don't see the rest of the application. So a model looks like that. So it's a function that you register on the core and expose an init and a destroyed method, and gets a sandbox injected. The sandbox itself, it's the only thing that the models see. They don't know which other model are already in the page. They don't know how the core works. They just know about their own business logic and the interface of the sandbox. That's why you should think about the sandbox and think what's the interface your application will expose to the models. So in this case, for example, the sandbox exposes a get user, which is the only way the model should get the information from the user, for example. It's just how it works, and it's kind of easy. And then there is the application core, which is supposed to take care of the life cycle of the models. So there should be something like the register function. You register the model to the application. Configure, if you want to inject the configuration. And then, the configuration gets injected in the init of the model itself. And then a start and a stop. And that kind of the life cycle management that I was talking about. And then there could be a library like jQuery or whatever else to deal with the DOM or base libraries. All these slides are stolen from Zaka's. I didn't do anything. So that's kind of it. And the cool thing about this one is that it marries quite well with an event-driven pattern. Are you familiar with an event-driven pattern? Have you ever used something like that? Okay, cool. I'm sorry, you'll see it again. So if we have something like that, which is perfectly healthy for the application, I mean, there is a sandbox with a layer method exposed that gets what? Opens a layer on your page. This could be something like that. So what happens actually is that instead of opening a layer straight away, I subscribe this function to this channel, this event. And when the event gets raised and published, this object with the property message and error occurred gets injected in as a payload in the function that I registered on the channel, and I can use it straight away. That's kind of how it works. The advantages of this approach is that it's more semantic because it's not just opening a layer. I know what's happening in my application. I have a channel that tells me what happened. It's flexible because I have just one entry point in which I can change the behavior. All the arrows should open in a layer or maybe not. And this is decouplable because I can remove this and, for example, on mobile, load another method that will subscribe to the same channel with a different behavior. So I will have maybe a layer on my desktop application, and with the same application structure, I may have a different behavior on another device, for example. It may seem over-engineering, but again, Zakas, the key is to acknowledge from the start that you have no idea on how this will grow. When you accept that you don't that you don't know everything, you begin to design the system defensively. This is defensive design, in my opinion. I do kind of like it. Another thing that could help you maintain your things clear and simple is AMD, asynchronous module definition. Anyone? AMD? Okay, you? Okay. So this is what happens in a complex web app. So you have a lot of stuff. You have libraries, you have plugins that are relying directly on the libraries, and you have your scripts that are relying on plugins or the library itself. And there's quite a huge mass of dependencies that runs around your application. And all the time you have to deal with that. And not just that, loading them, I mean, but also how you, oh, sorry. I missed a bit, I think. Oh, we have to look at that, sorry. So not just that, but there is a piece that I'm missing from a thing, but there is also a problem of namespacing. I mean, when you write your script, you just don't put them in the global namespace, right? You will have to write namespace and keep the understanding of it. So at some point, either you or behind the hood, your framework will do something like that. So there is a configuration for production and a configuration for development. You have a huge amount of scripts loading for development and one beautiful bundle compressed and minified and gzipped and whatever for production. Oh, here it is, the slide for the namespace. Yeah, and you have to deal with the namespace as well. I don't know if I mentioned it, but with the namespace as well. With AMD, you can get rid of all these things. So basically, there is one defined function that does all the magic, and everything gets sandboxed again. So we can see how it works. This is a module for AMD. And basically, the name of the model is the path of the file starting from the base folder you decide. So in this case, is app/config is the name of this module, which exposes and returns this stuff as the module itself. So you can use it straight away as a dependency for another library and require it, basically. It gets injected when it's fetched from an HTTP request, and you can use it in the function that defines this other method that is app/myProduct, which actually itself returns a function constructor that takes an ID and returns a getProduct URL. Then there is the app main, which is basically your core start, your uniter of the app, that looks something like that and requires jQuery. So yeah, app main, again, that's the path of the file itself. Requires jQuery, requires app product, uses it. And the cool thing about it is that this is the only thing you should have in your HTML. And on development, you will have the fetching asynchronously of all the dependency, and once the dependency gets fetched, the define function will be executed. And then you can optimize your app main, and all the dependency will get bundled by the server-side optimizer, and you can throw online the app main compiled with all the stuff within. And so that's the only HTML you need. So pulling all together, I've written my own small framework just to play with it. This is Akaze. Please go to GitHub and look at it. It's kind of, again, it's pulling all together all the stuff that I mentioned before. So it relies, instead of having a core register, it relies on a define function, and so on require.js actually, and returns the same structure that you saw before for the module. So init and destroy. And then there is the sandbox with the pub/sub pattern already exposed. And the core require works like that. So there is a start. So yeah, Akaze, there is a start, no register because the register is the define, and we don't need that. There is an inline configuration, and there is a conditional loading related to the event messages. Play with it. We do use that in Shazam. It's fun. But it's not a silver bullet. Silver bullet is not for zombies, it's for werewolves. Everyone knows that. There is no silver bullet for coding. This is something that works for me, for us. Try it. Maybe it works for you, maybe you need something else. Happy ending. That's a unicorn killing zombies, by the way. If you want a happy ending, that depends, of course, on where you stop your story. You can run and you can hide, but you're going to write shitty code anyway. Zombie code anyway. The thing is, you will. I do all the time, okay? There is no thing as I will write beautiful code every time. You will have deadlines. You will have to compromise with browser weird behaviors. You will have to do and to write bad code. Embrace it. That's it. The thing is, you shouldn't improvise. The thing is, you don't get not to write bad code. You get to learn how to deal with it afterwards, until you master it. That's the point of it. But in any case, just remember to aim for the head. That's it. I'm done. Thank you. If you have any question, I think I have time because I usually rush when I speak. I hope it was clear enough with my English because, okay, cool. Question? No? Okay, good. You can catch me afterwards. I will be here all day. Just one more thing. As I mentioned, I organized this conference in Italy, Front-End Brothers. This childhood blues, which is like Hadwood Blues, Blues Brothers, but with C in the front of it, is a discount code for the 10% you can use until, I believe, the end of next week if you want to join us. It's, you know, front-end conference, good speakers. Bologna is a beautiful city. Join us.